So today we're going to look at combinations. And all of the measures of success talk about combinations. We don't know what it is yet, so I won't go over those. But I'd like you to do these 2 warm-up questions and see what you get. And then we'll compare our answers. Question number 1, did you get 24? So I did it the long way. So I listed them all out so we could see all these possibilities. And also so we could contrast it with number 2, because number 2 should just be 4 possibilities, because all of these have the ABC. So if the order doesn't matter, then it's just one group that I could get. And here all of these are ABDs. The order doesn't matter. So kind of each column is describing the same set of letters. So we only have 4 sets that we could get. Should I explain something, or you need a minute? Who needs a minute to ask me your question? Okay, how many sets of 3 letters can be made? So here it's not asking us to arrange the letters, but just to pick a group of 3 letters. So if I have these 4 letters to choose, at this point I can just list them out. I could do ABC, ABD is distinct, ACD, or BCD. So each of these groups is different, but there's not another group of 3 letters that I can come up with. You're still puzzled? What if, let's try it this way. I don't know if this is going to help. A, B, C, D. So one group is those 3 letters. Another group is those 3 letters. Or I could have A and CD, or AB and, D. And I already have the ABC. So those are kind of showing different groupings of those. So I'm just choosing the letters, putting them in a group, but I'm not rearranging them once they're in a group. I don't know if that was any better, but if it's making sense to you, yay. Other questions? Question number 1. Yep. All the other ones that are listed. Here, because it has this 3-letter codes, kind of a code is a signal or a flag to us that, oh, the order makes a difference. Whereas in part B, it just says sets of 3 letters. So if I have ABC, that's the same set of letters as ACB, right? So these it's the same set, it's just a different order. But this one just asks for a set or a group of letters. So A is a permutation, B is a combination. So that's the difference between permutations and combinations. Which leads us to our definition here. A selection of objects in which order is not important, that is a combination. And let me look back here at number 1 and 2 for a moment. In question number 1, what I have is 4 letters. So we could think I'm going to arrange 4 letters, but I'm not going to arrange one of them, which would be 1 factorial. So this would be tied to the NPR thing, where I have 4 factorial over 4 minus 3 factorial. And that would be, let me move this over, oh, not that, all of this. This would be 4p3. Make sense? Now, in number 2, what I'm doing is I'm saying, well, from my 4 letters, I'm going to choose and arrange all 4, but I'm not going to arrange one of them because I didn't choose it. But I'm also not going to arrange the 3 that I did choose. So I'd have choose and arrange all four, but I'm not choosing one of them and arranging it, and I'm not arranging the three that I did choose. So we've said that and means multiply, so and not means divide. That's why I'm dividing here. Here I'm choosing and arranging everything in the numerator. In the denominator, I'm not arranging the 1, and I'm not arranging the 3, which gives us 24 over 6, which is 4. So if I have a 3 factorial on the bottom there, I could have a 3 factorial on the bottom here and 3 factorial on the bottom there. So now as I look at this, this says from 4 objects, I'm going to choose and arrange 3 of them, but I'm not going to arrange 3 of them. Which seems a little confusing because I'm doing something and then undoing it. But that's kind of how the math works in terms of the formula. Yes, Cameron? I'm saying that I'm not arranging the 3 letters that I picked. So here, I picked these 3 letters. If I was arranging, I'd have 6 ways to arrange those 3 letters. So the 3 factorial, that's equal to 6. So I'm not going to find the 6 different ways here that I could arrange them. I'm just going to consider it just one set of those 3 letters. So that sets us up for this formula here. The NCR is kind of familiar. It looks like NPR, but now the C would be a combination. In front of it, we have this different notation. So on the formula sheet you received yesterday, it'll include both of these. And we're expected to understand what each of them means. They both mean the same thing. 2 different notations for combinations. When I was in high school, I only saw NCR. When I left high school, I only saw this N over R in brackets thing. Notice it's not a fraction. There's no line in between. Has to have these brackets or it means something different. So this is how it would be written. And we'd say N choose R is often how we say it. And the idea of choosing is we're not arranging. So even though this C actually means combination, often we'll think about just choosing. So from N objects, I'm going to choose R of them. And when I'm choosing, I'm just getting a group, I'm not arranging. So similar to the way I wrote it above, this is the same as if I did a permutation, but didn't arrange the R objects that I chose. So that's what we had up here. I did this permutation of 3 objects, but I didn't arrange the 3 objects that I had. That's why I divided by the 3 factorial. Simplifying this, NPR is n factorial over n minus r factorial. And then if I divide it by r factorial, that division ends up getting multiplied into the denominator. So kind of a more complicated formula for an idea that's actually a little bit simpler. As it's saying, if I want from n objects to just choose r of them, this says I'm going to choose and arrange all of them, but I'm not going to arrange what I chose. I should say what I didn't choose, and I'm not going to arrange what I chose. That's where the denominators come from. Fortunately, for the most part, we'll just use the NCR and we'll be fine. So let's look at number 3. Lotto 649 allows a player to choose 6 numbers between 1 and 49 inclusive. What does inclusive mean? Armand? Yeah, so we're including the 1 and everything else up to 49. So inclusive is a term that has shown up on diploma exams, so we should be familiar with it. That means we include the 1, we include the 49, so we have 49 options. How many ticket combinations are possible? So notice they're even using the word combinations in this question. So if you've ever bought a lottery ticket, it's been a long time for me, but I think you just shade in little bubbles, right? So the numbers show up somewhere, and even when they do the draw, what they used to do when they made a big deal of it on TV was they used to have balls bouncing around in this thing, and then they'd roll it around, and as it spun, eventually one would come out. And then it didn't matter the order they came out, we were just getting 6 different numbers. Once they had all the numbers, they'd rearrange them from smallest to largest. So order didn't matter. So we'd say from these 49 different numbers, I'm going to choose 6 of them. And again, the other notation would be 49, choose 6 like this. If I wanted to use the formula, which normally I wouldn't, but we'll write it out for now, that would be 49 factorial over 49 minus 6 factorial times 6 factorial, which is 49 factorial over 43 factorial times 6 factorial. So you'll notice in this formula, the 2 numbers in the denominator will always add up to the number in the numerator. And you'll find the button for combinations the same place you found the button for permutations on your calculator. Well, let's just evaluate that. I get 13,983,816. So what's the probability that you're going to win the grand prize from this lottery? Probability is not part of this course, but you know, this kind of probability we could figure out. What's the probability? One in how many? Oh, good question. Let's imagine you're just buying one. Because every time you buy another one, that will increase your probability of winning. So suppose you just buy one, good question, then 1 in almost 14 million. So if you are logic and mathematically minded, you'd say, what's the point? And if you have dreams and say, well, somebody could win, 1 in 14 million is still a chance, then you might buy a ticket. I bought a ticket once, maybe more than once, but one time I was walking through the mall. This was a long time ago. Walking through the mall, and I saw one of those signs that says, win $5 million in this lottery thing. And I thought, yeah, it's only a dollar, why not? Not a daughter. I didn't sell my daughter to get a lottery ticket. Let me be clear. It was a dollar. Yeah, so I thought, it's only a dollar. Why not see what happens? But then I stopped and I thought, basically I'm throwing away a dollar, right? My odds of winning are really slim. So then I thought, if I can just throw away a dollar that easily, if I won $5 million, could I just give it away as easily? Which got me pondering. And so I went home and I chatted with my wife and said, do you think we could do this? And so we had this long conversation and we made up some rules. Like we couldn't benefit from wherever we'd give the money. And we wouldn't give it all to one place. We wouldn't give it to family or children or anybody that we knew. But we'd find somewhere that we could give this money and eventually have given it all away. So we came up with this agreement that if it's that easy to throw away a dollar, then whatever I get from it should be that easy to just throw away, more or less. So I went back to the mall, I bought my ticket, and I didn't win. I didn't even win a small prize. So I didn't even have $10 to give away. I just lost my dollar. There's my story. Yep. Well, questions with this one? questions with my story. I still have 2 daughters. One of them I sort of gave away because she got married a year ago. Pardon me? 1.5? Well, I don't know. Half, or did I gain a son or something? Question. Pardon me? Which mall? It was when I lived in Burnaby, BC, and what was the name of the mall? I can't remember the name of the mall. I don't know. So it wasn't in this area. But it would have been in my first 5 years of teaching because I taught there for 5 years. Many, many years ago. Let's look at some more questions. Suppose you have 8 people and you want to find out how many different committees of 3 people you can select. So, what we're going to find from here on, as questions get kind of mixed together, is we need to distinguish, is this a permutation or a combination? And usually we want to figure that out at the start of the question. And if we make that decision wrong, everything after that is wrong, which is part of the challenge of this chapter. There's some ways around it, and I'll talk about that as we get through. As in, if I'm not sure, I have a strategy. So for this one, here's what my strategy would be. Suppose I don't know if it's permutation or combination. I'm going to start by imagining it's just a combination. So all I want is a group of 3 people. So I'll say, from these 8 people, I'm going to choose 3 of them. And then I would stop and I'd say, once I have my group of 3 people, have I finished the question? Yeah, that's all I need for this question, right? So I just do 8 choose 3, and I think this is 56. Can anybody check that for me? It is. Thank you. So let's look at the next one. From a group of 8 people, 3 must be selected to form a committee with the president, secretary, and publicist. Okay, so I'm going to say, oh, I don't know what this is, so I'm going to start again. 8 people, I'm going to choose 3 of them. Once I have my group of 3, have I finished the question? No, because they have jobs they need. So what I would do is I'd say, well, I've chosen my 3 people. Now I'm going to arrange those 3 people. And this would give me, I think, 336. Again, somebody could double check that for me. Or maybe you read this question and you said, oh yeah, I know that's a permutation. In which case, you do 8p3, and again you get 336. So when I'm confident that it's a permutation, I'll just jump right to what I've written in green. When I'm in doubt, I'll start with a combination and then ask if I finished the question or if I need to do some sorting and arranging afterwards. And it'll get me to the same answer. Questions? All right. Now we're going to do a series of questions that are connected to playing cards. I've never seen a question with playing cards on a diploma exam for a few reasons. Not everybody's familiar with playing cards, and it would take some explanation. And historically, and I don't know how much it is now, some people have had issues with playing cards that it's not something we should be doing. And so they will not use them on a diploma exam. But they're so handy, so I actually use them in the examples. Question? Order does matter, yes. Because not only am I selecting the people, I'm assigning them roles. So when we say order matters, it's not always that I'm kind of lining things up in a row. It could mean something like this, that once I have them in my group, I'm arranging them into different jobs, which is what's happening here. Or arranging them somehow. Yes? The 8p3? Yeah, so this would look like 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. Whereas what we did in blue, let's look at that one too. We'll do black. The 8c3 would be 8 factorial over 8 minus 3 factorial times 3 factorial. But then we multiplied it by 3 factorial. So the end result was that those canceled out, and we got the same result in the end. So playing cards. There are 52 cards in the deck. If I use questions related to playing cards on a test or quiz, I will give you all the information you need in the question. So don't panic. Here we have 2 suits that are red. They are hearts and diamonds. A suit is kind of a collection of cards. So they're grouped. In this case, they all have the same shape on them. And 2 suits are black. These are spades and clubs. That's the shape that's on those cards. There are 13 cards in each suit, 1 through 10. So the 1 is called an ace. And then we have 3 cards called face cards because they have pictures of people on them, which is a jack, a queen, and a king. So we have 1 through 10, 11, 12, 13 cards with each shape on them, okay, in each of those suits. How many different 5-card hands can be formed? Well, in total, I have 52 cards, and I need 5 of them. Now, with card questions, every time, unless you're told otherwise, which is almost never, the order doesn't matter. If you're someone who has played any type of card game, most card games, when you're dealt cards, you pick them up and you sort them as you like as you're holding them. So the order you were dealt them doesn't make a difference. There are games where the order will make a difference, but most games don't. So generally we'll assume order doesn't matter with card games unless you're told otherwise. So we'll just do this calculation and we'll get some big number. Which is 2,598,960. Easy enough. So let's change things up a bit. Suppose you want 5-card hands, but they only have face cards. In other words, they're only made up of jacks, queens, and kings. Well, what we can do is we can, in our minds, separate out the deck into 2 groups. So I'm going to look at a group of face cards and then a group of non-face cards. And from the group of face cards, there are jack, queen, king in 4 suits. So 3 times 4, there are 12 of them. And I want my entire 5-card hand to be made up of face cards, so I want to choose 5 cards from that set of 12. And so here I want 5 face cards, 0 non-face cards. So if there are 12 face cards, 52 cards in total, 52 minus 12, 40. So there are 40 non-face cards, and I want to choose 0 of them. So I'm going to choose the face cards, and I'm going to choose 0 non-face cards, and means multiply. So when I do 12, choose 5, I get 729. Nope, 792. And I did that this morning too. 792. And imagine there were 40 people in this class, and I selected a group of 0 people. How many different groups of 0 people can I get? Just 1. They all look the same. Nobody's in it. So there is 1. So this is a 1. You could plug it into your calculator to work it out. So because 40 choose 0 is 1, often we leave this out. So we could have just done 12 choose 5, and that would be our answer, 792. But sometimes, just to be careful, it's helpful for us to make sure we're considering the entire deck. So you'll notice this 12 and that 40 add up to 52. So I've considered all the cards in the deck. And this 5, that's supposed to be a 5, and that 0 add up to 5, and that's how many cards I want. So I've considered the entire deck, and I've considered in total how many cards I want. If you choose to leave off this 40 choose 0, that's fine. You still get the right answer. Number 8. How many different 5-card hands can be formed containing exactly 2 aces? So I want 2 aces. Is 2 cards enough for a 5-card hand? No. Which means I want 3 cards that are not aces. And again, the ace is the card that has a 1 on it. So like the previous question, I'm going to separate the deck in my head into aces, and there are 4 aces, and I want 2 of them. And out of 52, if 4 of them are aces, that means 48 aren't aces. And to complete my 5-card hand, I need 3 more cards. So again, as we looked at in the previous question, what I'm choosing from adds up to the 52, the total deck. And how many I'm selecting, the 2 and the 3, adds up to my 5-card hand. I'm doing both things, so I'm multiplying. So I'm choosing the aces and I'm choosing the non-aces, which gives us multiplication. 4 choose 2 is 6. And 48 choose 3, 17,296. Giving us 103,776 different hands we could get. Yes, Mohammed. Can you say that again? Okay. Yes. On the Inspire, you'll go to Menu and then Probability, and then in there you'll find combinations and permutations. There's a quick button for factorials, but not for combinations permutations, as far as I know. Questions? No questions. Okay, so we go one step more difficult. We want to know how many 5-card hands can be formed that contain at least 1 ace. So, at least 1 ace means I could have 1 ace, and I need 4 non-aces. So I'm going to use a notation here that we don't have to know, but because I know this is going to take up a lot of space, I want to keep it brief. So in set theory, which is something the 30-2s learn about, typically sets are described with uppercase letters. So here I could use, say, this A is the set of aces. If I have this little prime or tick symbol beside it, that means it's the complement of set A. In other words, it's everything in my deck of 52 cards that's not an ace. So this is the same as saying what's not an ace. You don't have to know that, but that's just my abbreviation that I'm going to use up here. So I have 1 ace and 4 non-aces. Or I could have 2 aces, and then I need 3 non-aces. Or I could have 3 aces and 2 non-aces. Or I could have 4 aces and 1 non-ace. And there are only 4 aces in the deck, so that's as far as I can go. So there's a fair bit of calculating to do in this question. Whenever we have questions with at least or at most, sometimes there's a shorter way to do it. So I'm going to write out what our calculation would look like, but then I'm going to stop and I'm going to do it a shorter way. So if we did it this way, we would have, from my 4 aces, I'm going to choose 1, and means multiply. From my 48 non-aces, I will choose 4. Exactly 1 ace and exactly 2 aces are mutually exclusive. So I could have 1 ace, or means add, I could have 2 aces, or 3, or 4. So those will be additions where I put the ors. 2 aces would be, from the 4 I'm choosing 2, and means multiply. From the 48, I choose 3 non-aces. Now, before I go any further, let me just kind of address a question that sometimes comes up. Suppose I had the ace of spades and the ace of diamonds. There's not just one hand that has an ace of spades and ace of diamonds. There are still, 48 choose 3, other possible sets of cards that could be mixed with these two. And so just by choosing the 2 cards, changing the other 3 cards gives me a different hand. So I'm not just looking for when I get the ace of spades and the ace of diamonds, I'm looking for all the other possible cards I could get with it because they're distinct. Okay, on to the next one. From 4 I choose 3 aces, and from 48 I choose 2 non-aces, or 4 choose 4, and 48 choose 1. No. Yes. That's what I want. And I want to look at that last one for just a moment. If I have 4 aces and I choose all 4, how many different groups can I get? 1 group. Yeah. So whenever your n and r value are the same, you will get 1. So if you have n choose n, it will equal 1 every time. Just as a side note here, n choose n equals 1. Whereas with permutations, npn was equal to n factorial. So here I'd be arranging all of my objects in the permutation. With the combination, if I only have 4 things and I choose all 4, there's only 1 set that I can make. Yes? I'm just saying if my r value is equal to n. So if they're the same number. So this special case. Another handy one to know, if I have 48 objects and I'm going to choose only 1, how many sets of 1 could I get? I heard something, yes? Yeah, 48. So n choose 1 is equal to n. And that'll always be the case. So with some practice, you'll see some of these patterns that can save some time. But I'm going to need this space again, so I'm going to erase it. We could do this whole calculation. It'd be rather time consuming. In this case, we could find a shorter method. We could look at what are all the hands we could get. So think of all the possible 5-card hands and then subtract out what we don't want. What don't we want? A hand with no aces. So I don't want 0 aces and 5 non-aces. So there's going to be less to calculate here. So when we can find a quicker way to calculate, it's just more efficient, fewer places to make a little careless mistake. So it's a good idea if we can recognize this. So all the hands was 52 choose 5. And on the previous page, we actually calculated this to be 2,598,000. I can't remember. Yep, 598,960. So those were all the possible 5-card hands we could get. And we'll subtract off 0 aces, so 4 choose 0, which is equal to 1. So I could leave that out, because 1 times anything will keep the number the same. And 48 choose 5 cards. Which is 1,712,304. And we get 886,656 different hands with at least 1 ace. So if you ever have a question with an at least or at most, that's a good flag that you're going to have to do a couple calculations at least and then add them together, or subtract them in this case. The subtracting isn't always the quickest way. Sometimes adding will be quicker. So it all depends on the numbers you had. So for example, if it said at least 2 aces, then you could do maybe at least 3 aces would be even better. If you had at least 3 aces, then you'd consider 3 aces or 4 aces. You'd only have 2 sets of calculations to add together. That'd be better than the complement, which is all of them, minus 0, minus 1, minus 2. Yes, Trab. Because I'm considering of all the possible hands I could create, there's some hands that I don't want. So what I don't want, I'm subtracting out. I don't want 0 aces and 5 other cards. So that's going to leave me with what I do want. Good. So questions with at least or at most are considered standard of excellence questions. So can't see a lot of those, but you could see some. This would be a situation where there's probably enough work to show that it might be worth making this written response. And there's so much work that having it multiple choice, I don't know if it's really worth multiple choice. I guess it could. It's not going to hurt you that bad if it's only multiple choice. Okay, questions? No questions. Have a look at this, check your understanding question. And then we'll go over it shortly. So of these 7 options, which one did you pick? I'll count down and then just shout out your letter. Oh, if we get a good shout, we'll do the gong. Okay, here we go. Oh, there we go. Here we go. 3, 2, 1. Oh, wow, shout. Yeah, that wasn't much of a shout. You were in unison. That was good. We get a bell. Oh, that reminds me. I brought in some other sound things today. I like sounds. They're interesting. Oh, hello. I'm really close to the microphone. I brought my frog. Nice, eh? It actually sounds like some frogs. Have you ever heard a frog like this? Okay. And this one I haven't done in eons, so I don't know if it's going to work. Oh, I need to do the outside. I need more practice. Is anybody good at this? It's supposed to sing. It's not working. I have to practice. So I could just ring it like that, but that's not the point. As you get going around the edge, which I think is the outside edge, somebody must know what they're doing here. Put it on the table, you think? Actually, it should work in my hand too, but we'll try it on the table. Slower. Oh, it started coming. Ah, well, there you go. Some of my sounds, but I looked at my goat bell and thought, I don't know if I want to bring that in yet. It's one of my favorite sounds. Can I tell you about my goat bell? Didn't I? Oh, I didn't? Well, when I lived in Kenya, kind of when you're out in the middle of nowhere, you'll hear kind of a little jingle, jingle, jingle of goats that have the bell, so that whoever's looking after them kind of knows where at least a few of them are, because they don't all have bells, but some of them do. So it was such a pleasant sound that I became accustomed to that when we left in a market, I bought a goat bell. So when I go hiking, if I think I need a bear bell, instead of using a bear bell, I use a goat bell. But it sort of entertains me because I think there's this little jingle, 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 which sounds, it's a goat. Oh, it's snack time. I'm actually inviting the bears. Because if they hear a little bell, they think it's a goat, maybe? No? Okay, fine. It's hard to tell, hard to read reactions with these masks on. You all just look bored. Okay, fine. So G is what you picked for this question. Oh, look, I recorded all this. Oh, well. You get to hear it again if you choose. I'll post it on Edsby for you. Okay, so we picked G. What's the mistake somebody might have made that would have resulted in them choosing F? Come on. Yeah, 3 cashiers or 4 store clerks. Then we would have been adding instead of multiplying. What about E? Yes, Rohan. If they thought it was a permutation, how would this question have been different if it was a permutation? A restriction, could you give me an example? Cameron. So if we were assigning roles for each of them, like say there's going to be a morning cashier, an afternoon cashier, and a night cashier, and you needed to assign them to the different roles, that sort of thing, then you'd say order matters, because you're not only choosing the group, but you're actually giving them jobs or giving them special roles. And then D would be if it was or instead of and. Any of the other these? How about if we look at just B? What's happening in B? Cindy, do you have any ideas? No, you're just staring at the board, hoping I don't ask you. Okay. Hadlin, you don't even know what we're talking about, do you? That's okay. So my question is, as we look at B, what is this calculation describing? It's not the right answer, but what is it describing that's different from the wording in the question? Cameron, you had an idea. Okay, so we're adding all the applicants together and just choosing 7 people. So it's imagining that these people didn't apply for specific jobs. They just applied for something at this store. Okay, and then what? Yeah, so then assigning 3 to cashier, and then the leftovers, 4 choose 4 would be 1. You'll just have 1 group left, and they'll all be the store stock clerks. Okay, good enough for that one. Again, reminder, and means multiply, or means add from mutually exclusive choices. And we've looked at this a number of times, just continuing to remind ourselves. So now our measures of success, we can explain what a combination is, a selection where order doesn't matter. We can use combinations to solve problems, and hopefully we can distinguish why is a problem a permutation or a combination. So let us do one release diploma exam question. Diagram shows a website seating chart for an aircraft. Seats shaded black have been reserved. The light sheets are available. 12 seats are available. So we have an empty seat. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 empty seats. Yes. Yep. If 7 customers are each booking 1 seat, then the number of different ways they could be assigned a seat is which of these? Take a few minutes, see what you can come up with. Hello, people in video land. So we just had a vote, and we're pretty evenly split between C and D. D, I think, was a little bit more. Who would like to present their case? Which one do you think is right and why? Yes, Karen. So put them both into a calculator, and what were the numbers you got?
One was like 39 million, no, like 3,991,000.
And then you said, oh, it must be D. So you went with D because the number looks more reasonable. Okay. Anybody convinced? Anybody want to change from C to D? Nobody wants to admit it, at least. Anybody like to argue for C? Or a different argument for D? Anybody want to go home? No, you don't. Oh, lots of people don't want to go home yet. Okay. I hope that doesn't mean home is bad, but. So, well, let's think about the question. Oh, please. Okay, so you're thinking combination because there aren't added restrictions? Okay. Kira. So a number of different ways. So that's leading up to what I would say are kind of the key words. So let's stop for a second and say, well, we have 7 passengers. Suppose I pick 7 seats. Let's do green. So I'll pick this one, and this one, and this one. 1, 2, 3, 4, 5, 6, 7. Once I've picked those 7 seats, am I done? So we look back at the question. 7 customers, each booking 1 seat. Then the number of different ways they could be assigned a seat. Are customers in seats yet? Or did I just pick where they're going? I only picked where they're going. I still need to assign them seats, which means it's a permutation. Oh. No wonder only 38% of people got it right the first time. Now, this is all new to us, right? So we're still going to do lots of practice. In fact, tomorrow, the full day is practice. So no new lesson tomorrow. We'll go over a couple questions together maybe, and then you'll have lots of time to work on different questions, and I'll help you out as we go. Yes?